All right, and then the last objective here, we're going to talk about simulation. So again, simulation is what we did to create those dot plots when we did the questions in 3.3 and 3.8 on statistical significance and convincing evidence. All right, so a very important idea here. So a simulation is used to imitate chance behavior. Remember, when you look at the dot plot, it is how often something occurs by chance, right? Okay, so when you perform a simulation, you state the question, you plan on how you're going to do each repetition, you perform those repetitions, and then you conclude based off the results. And the conclusion part, again, is the most important part of this class, so be aware of that. Okay? All right. So let's take a look at an example and see what we can do. All right, so this is over 2 slides, so be aware of that. So it says, in an attempt to increase sales, a breakfast cereal company decided to offer a NASCAR promotion. Each box of cereal will contain a collectible card featuring one of these NASCAR drivers: Jeff Gordon, Dale Earnhardt Jr., Casey Kane, Danica Patrick, or Jimmy Johnson. The company claims that each of the 5 cards is equally likely to appear in any one box of cereal. A NASCAR fan decides to keep buying boxes of cereal until she has all 5 drivers' cards. She is surprised when it takes her 23 boxes to get the full set of cards. Design and carry out a simulation estimate the probability that it would take 23 or more boxes to get all 5 drivers' cards. If the company's claim is true, what conclusion should the fan draw? All right. So here we go. All right. What the heck did they just say? Well, think about this situation, right? And I remember when I was a kid, right? They had baseball cards or whatever. So you got these 5 drivers you want. So, I don't know if, I know Casey Kane is the one I really don't know. So say like Casey Kane, no one likes him. So his card is in every box. So say I get like 20 Casey Kanes, right? And then like 1 Jeff Gordon. Like I remember if you wanted like the Michael Jordan card, you never got the Michael Jordan card. You would always get like the I forget the Armstrong. I forget his first name, but you'd always get BJ Armstrong. You always get like him or like Ron Harper, but you never got Michael Jordan. So again, it's the same idea of, is the company telling the truth, right? Do they really have equally like chance to get all of these drivers, or are there more popular drivers not in there so much so that you keep buying the cereal, and the least popular drivers, they just threw a whole bunch of their cards out there? Okay, that's the idea. So again, stats is kind of cool. It can help us test this. So first of all, what is the question we want to ask? Okay, well, it comes from here. It comes from here. We are trying to estimate the probability of taking 23 or more boxes to get all 5 drivers' cards if the company's claim is true. So that's our question. What's the probability that it would take 23 or more boxes to get all 5 drivers' cards if the company's claim is true? Claim is true. Sorry. So I was right. So company's claim is true. Okay, so there we go. That's the question. So how are we going to plan this? We have to understand the situation, right? So the company's claim is that each card is equally likely. So for each card, you have a 1 out of 5 chance, or a 0.2 probability. Okay? Well, to simulate this, you need to use 5 and let each driver equal 1 of those 5, right? So in this problem, if you had something that had 5 things on it, you could use that. Like a coin only has 2 sides. A dice has 6 sides, so you could use those. But you can also just use numbers. And I'm going to model it this way. I would suggest you do the same thing for your problems on your homework. So let's just use numbers. So let's let the number 1 equal Jeff Gordon. 2 equal Earnhardt Jr. And so on, right? So 3 is Casey Kane, 4 is Danica Patrick, and 5 equals Jimmy Johnson. Okay, so there we go. So we got each person, each driver has a card. So now what we're going to do is we're going to use a random number generator. And we're going to choose one number to choose, one number. And that has to be from 1 to 5 at a time. So this is just like if I were to get a cereal box, I pull out the card, I see who it is, right? Okay. So what we have to do is our goal is to get all 5 drivers' cards. So we need to continue this process. Continue choosing numbers one at a time. So continue choosing numbers until you get each number 1 through 5 at least once. Record the total number of numbers needed. The total number of numbers needed. So that's kind of confusing. I'll do an example when we get to the I do an example here. So say, like, for instance, right, you get a 2, then a 4, then a 2, then a 3, then a 1, then a 1, then a 5. Stop. 1, 2. So at this point, I have at least every number once. I have a 1, I have a 2, I have a 3, I have a 4 out of 5. So this sample would be 1, 2, 3, 4, 5, 6, 7. That would be a sample of 7. That means it took me only 7 boxes to get the numbers 1 through 5 at least once. So this is my example of what a sample would be. Okay, so hopefully that makes sense. Now again, we're not going to do this ourselves. We're going to use a random generator to simulate this many times. Okay, all right. So far so good. Okay, great. Next, well, here's the dot plot now. You see I added that. Notice it does 50 repetitions. So we're going to perform 50 repetitions. And again, you should be getting the dot plots for all your problems. So perform 50 repetitions, and now we have to do a conclusion. So now the question was 23 or more. Remember that our percentage is 5%. So how often does it take, or how often did 23 or more occur? Well, in between each of this is 5, this is 6, 7, 8, 9. So up at 20, 21, 22, I think this is 22. So I don't even think 23 is on here. So 23 or more occurred 0 times out of these 50 repetitions. It never happened, which means this result is not likely to happen by chance if the company's claim is true. Uh-oh, but it did happen. Happened. We needed too many boxes. Maybe this company's claim is not true. Maybe they are, in fact, lying to us. So this is going to be very similar to how we did that statistically significant question. Okay, three sentences. First, we're going to say, 3 sentences in 50 simulations. Opening. And you can word this however you want to. Opening 23 or more boxes to get all 5 driver's cards. Never occurred. Zero out of 50, which is 0%. The estimated probability, so this is the new part because again, we're trying to tie in probability. The estimated probability, that word probability always trips me up. I want to do the I so fast. Probability is 0. The estimated probability is 0. Therefore, this fan has convincing evidence that the company's claim is false. And that's because 0% is less than 5%. Okay? So again, if we think there's an equally likely chance to get each of the 5 cards, if we're really good, it would take us 5 boxes, right? 1, 1, 1, 1, 1, right? 1, 2, 3, 4, 5. Okay, but I think that would be too much to ask for. So again, we're thinking maybe it's going to take me 8 boxes, maybe 11 boxes, but not 23. So because it didn't happen often by chance, we are right. It shouldn't have taken us 23. They are probably lying. There's probably not an equally likely chance to get each of the cards. All right, so do your best with this, and we'll talk later. All right.